Hello, I'm Rob Barwick, Adjunct Technical Instructor for the American Boat and Yacht Council, and today we're going to discuss wire terminations and connectors. And we're going to be going over best industry practices for making these connections. And the bulk of our information is coming from ABYC E11, AC and DC electrical systems on boats. And important that you're aware of this standard because this standard is used in over 15 other standards, such as H22 bilge pumps. If you're hooking up a bilge pump, you have to make an electrical connection. So that connection must be done to E11 ABYC standard. Seacock H27, all right, requires a bonding wire. So right here you'd be making connection. So again, referencing that E11 standard. So we're going to be discussing the ins and outs of the different types of wiring, the different types of connectors, and different ways you can make these connections. And one of the biggest issues that we have with electrical systems in boats is unwanted opens and corrosion. So we're going to talk about what we can do to mitigate this corrosion and prevent these problems. And as we get into these newer boats, we see that they're more complex and they're more electrical based. And we're getting into different types of switching and connections where electrical is more important than ever before, and we want to try to mitigate the issues with voltage drop. And discussing this stuff, we'll talk about what we can do to prevent all that. Before we get started, let's talk real quick about safety. When working with DC circuits, you want to make sure that you turn off the battery switch. If you're working with any of the battery cabling and stuff, you want to make sure you disconnect it from the battery. Battery voltage or DC voltage under 50 volts can't shock you, but because of the amperage in the batteries, it can still cause severe burns. AC is a completely different story. AC is very lethal and can kill you. If you're not sure what you're doing with AC systems, I would tell you don't get involved. Let someone else handle it. But basically, when you get on board a boat and you're working with the AC systems, you want to make sure you're disconnecting the shore power cord at the dock. Now, the boat can still have an onboard inverter that can still cause shocks. So you need to make sure that there's not an inverter on board, and if there is, you're going to need to disconnect the DC supply to that inverter. Another way you may be able to check if you have AC on board is just basically using an AC indicator. This little device here can be bought at any hardware store basically, and we're going to take a wire, and if it's got AC present, we can go and it's going to give us an indication. And we can go to an outlet and we can take the probe and just put it near the outlet, and if it's live, we're going to get a signal. So just a real quick way to indicate if we have AC presence still on board. And one last thing, with working with gasoline-fueled boats, remember that gasoline is extremely flammable and can explode. So make sure when you're working at any of these wires or any of these systems that you do not create any sparks. So now we have this piece of boat cable, and we want to put a termination on the end. So keep in mind when you're putting a terminal on these wires, whether it's a battery lug or just a regular terminal, is that when we make this connection, it's got to be secure. So we have to make sure the mechanical part of the connection is going to be able to hold on there. We want to make sure that this end can't fall off or the wire is going to pull out. So we have to make sure the connection is mechanically secure. And we have to make sure that we have electrically appropriate connector. So we've got to make sure that this connector, when it goes in there, is not going to build up resistance. It's not going to cause any voltage drop. It's not going to cause a loss of current flow going to wherever it needs to. So two things we've got to keep in mind when we're doing that is just making sure that we don't damage any of the conductor when we're putting this end on. So if we strip it, and we'll show you some ways of doing it, when we crimp it, we cannot remove any of the strands. We don't want to alter the strand count in any way, shape, or form. So we've got two different lugs here. I've got one that's just a solid lug, typically for a battery cable, and I've got one that's a crimp-on style lug. And I'm going to talk about this battery lug first. And in the past, a lot of people would solder their connections on. So they would actually use solder and put that wire in here and solder and make a hard connection. And people like that because it would make a nice connection and it's sealed up. The issue with that is, the problem is the solder is going to get on that wire and make that wire very stiff, almost like a solid wire. And from vibration, this end moving back and forth, a lot of times it would cause that wire to break. Another issue with solder is if the terminal should become loose, especially on a battery terminal, that's going to create a lot of heat. In some cases, the heat builds up so much that it actually melts the solder, and now this wire comes out. And if this is a live wire, could cause a short circuit and possibly a fire. So for those reasons, soldering wires has gone out of favor, and it's not actually allowed by the ABYC except in battery cables, and we'll talk about that later on. But what has come into favor really is the crimp style connector. And what we're going to be doing is talking about different ways to put these on and some different styles and some of the tools and the appropriate way to put these crimp connectors on so that it doesn't induce any voltage drop and cause any issues. So we have a bunch of different crimp type connectors here on the table. And the first one I want to talk about is this guy, a wire nut. So wire nuts are not acceptable for making wire terminations on a boat. And for a couple of reasons. It's typically the inside of the wire nut, the part that actually grabs into the wire, is made for threading onto solid wire, but we're not using solid wire, we're using stranded wire. And what happens is when we take that cap and we put it on the strands, it usually just moves the strands around and actually has a habit of cutting the strands. Also, the inside of that wire nut is typically made of steel, which is not going to hold up in the wet marine environment. And also, really, there's no way of sealing this up. And people wrap electrical tape and put caulk and stuff in there. And the bottom line is none of it works. So do not use wire nuts. They are not acceptable or approved for use on board boats. Over here, we've got some different styles. And the first thing I want to talk about is these ring terminals. So I'm going to pick up this ring terminal here, and it is a crimp type terminal. The wire comes in, and we're going to use a tool, and we'll show you later on how to do that. We're going to crimp that to hold that wire in place. So the first thing I might know is this yellow sleeve on here. So that sleeve is for two reasons. The first thing is the yellow actually tells me what size wires it will accept in the end. And the other part of that yellow is that it's an insulator to stop that crimped area from coming into contact with anything that's going to cause an issue. And besides that ring terminal, we've got different diameters up top. So we can see this one has a hole in it. It's about 3/8. And we see we have some different sizes here. We can drop down to a smaller one, and we have to make sure that we get not only the appropriate sized barrel for the wire, but also the appropriate size ring terminal. And over here you'll see we have this block, terminal block, and we want to make sure if we want to put a connector on this stud, we want to make sure we're using the right size terminal for the right size stud. So looking at that, you might say, okay, hey, that one is the perfect fit. That's good. See, it's on there nice and tight. Going to get good contact on the plate, and the nut will come on there and we'll have good contact top and bottom. What you don't want to do is use a terminal that's too big, perhaps something like this, where you are minimizing the contact area because this hole in the ring terminal is so big. All right, you're actually creating an issue there where you're going to have less surface area and less conductivity. And the same thing even with this large battery terminal. If I was to use this lug for a larger wire, you can see that it's not going to sit on there real good. And even when I put the nut on there, you will find that there's a lot of spacing. And even the nut is bearing on a very small area of that terminal. So again, creating an area of resistance and voltage drop. So the ring terminals. Not only are they available in different size rings, but the terminals themselves are available for different size wires, and we'll see that right here. So the first one we see is this red one, and this ring terminal has a red band on it, and that means it's able to accept 18 to 20 gauge wires. So remember, we're talking about really small wires in American wire gauge. All right, so here's an example of an 18 to 20 gauge wire. All right, so that's something that the red terminal would be appropriate for. The next ring terminal I have has a blue jacket on it, and that blue jacket is for 14 and 16 gauge wires. So we're looking at something about that size. The yellow terminal is for 10 and 12 gauge wires. All right, so we can see these wires, all right, are getting larger in diameter as the number is going down. This burgundy connector on the end is for an 8 gauge wire. And here's going to the next step, we can see a battery lug, which we'd be using on, typically when we get below maybe 6 or 8 gauge wire, we're going to go to lugs. So a couple things when we're picking these out. we have different size wire requirements. We have different ring requirements for the ring terminals. Let's move over here to butt connectors. So the butt connector is used to put two ends of wire together. Now you can see there are three colors on the table here. So a butt connector may be used for something like this. I have two wires, I need to connect them together. I've got a bilge pump, I put it in the boat, I need to connect it to the boat's wiring. Typically we're going to use a butt connector. And so we're seeing examples of the three common sizes here for butt connectors. That red for the 18 and 20 gauge, the blue for the 14 and 16 gauge, which is the example we have here, and the yellow for the 10 and 12 gauge wire. Over here we have what's called disconnects. This first disconnect I have, you see, basically has a female, okay, and we've got this one that actually the jacketing is covered. Now these are very useful on switches, and you'll see them on the back of the switch. So we have these male side of the disconnect. All right, so if you crimp your wire on here, you'll plug it in and that will literally slide on. Now keep in mind that this may be a live terminal. If you're using something with a live terminal, a better one to use is going to be this jacketed, all right, disconnect, this female disconnect. So this way when you plug it onto that male, okay, it actually reduces the chance of having any contact. So these are the disconnects that we'll see. You can also get those disconnects to connect two wires in certain circuits where you have to unplug something. So we've got that male and female there. And another example you'll see is the bullet or the snap type connector. So it's again using a male and a female, and they come together. Now one of the issues with these terminals is over time from snapping them back and forth, what do you think happens is they wear out. And once they start to wear out, they can disconnect and cause an open circuit, possibly a live wire on this side. We'll get some resistance built up in there, voltage drop obviously from the loose connection. So there are better ways to connect wires, and we'll talk about this when we get into the actual connection part of it. Up here I've got what we call spade connectors. So now this spade connector, basically, very simple, and that's also made to go under a screw. Now this is not something we're going to recommend you using, but here is that bus bar again, and I'm going to say I need to hook up a wire to one of these smaller screws. So you can buy these type of spade connectors, you loosen up the head of the screw, you slide this under there, and people tighten it up. Okay, but over time you're in your boat, and from vibration, the boat moving, that screw can loosen up. And the problem is when that screw loosens up, is at this point that wire now can fall off. All right, and maybe this is hooked up to something, maybe this is live, maybe this is a ground and touches something live and causes a short. So we do not use these standard spade connectors. What we want to use in this case is a flanged spade connector. And it's got two little hooks on it, kind of like this at the end. And the whole idea of that is so when it goes on the connector and I bear down on it, with that flange on it, even if I tighten this up and down the road it loosens up, that flange doesn't allow it to pull off. The screw pretty much has to fall all the way out for that flange is going to come off. So that's a much better way of doing it. But in reality, the best way to do it would be to take one of these screws off and get an appropriate sized ring terminal, okay, for that. This way, this is not going to come off unless the screw comes all the way out. So that's going to give us a better connection there using that ring terminal and tightening it up. That would be a better way to go. Now I've got two other butt connector types over there to show you, and what these are called is step down connectors. So you see this one is blue, but it has a red band on it. And this one is yellow, but it has a blue band on it, and they are step-down connectors. And what that means is, let's say I'm working in a boat, and I've got a bilge pump, and the wire run from the battery or even from the console is quite far away. So because of voltage drop, the wire going to that bilge pump might be a 10 gauge, might be a 12 gauge, and the wires coming out of the bilge pump are only 14. So how are we going to connect those two? All right, one way of doing it with a connector is with the step-down connector. So we can take the yellow end, which is acceptable for 10 and 12, and put it in here, and have the blue end that's going to allow me to have my 14 gauge wire come in here and be able to crimp that. All right. The reason why we want to do this is when you are doing wire terminations, when we're stripping the wire, you cannot remove any of the strands, not one. All right, we do not want to damage the wire in any way, which is why you have to have an arsenal of connections here. So if you're working with a 10 gauge wire, you need to make sure you have the right ones. You don't want to use a blue end and remove, oh, I'll just cut some of the strands out and slide a blue end on there. Okay, and we'll see if we can do that. No, still not quite enough. Let me remove some more strands. Okay, and eventually I can get that guy to go on there and say, hey, look, now that goes on there. The only problem is I've cut some of the strands. So I've created a spot where there's going to be voltage drop here. So now I'm affecting this circuit and any voltage getting there just from cutting these strands. So the rule of thumb is make sure that when you are stripping these wires is that you're not cutting any of the strands and you are using the appropriate size connector for the wire. We've got laid out on the table here a bunch of different tools, and we're going to talk about preparing a wire for a connector or termination. And on one side I've got some different ways that we're going to go over on how to strip the wire. And over here I've got some different ways how we're going to be able to crimp the end on. So first I want to talk about is the wire again. So remember, we're using a stranded wire, never using a solid wire. And we have these crimp style connectors in blue, which means they're good for 14 and 16 gauge wires. And we've got the terminal itself, and we've got the PVC or nylon jacket that's on it. And I removed it to show you the barrel that's inside the crimp. So what are you actually crimping is this part, this metal. That's what's crimping onto the copper wire. And the jacket here is basically sliding over it. So if I hold this here and put the barrel over it, you can see the barrel is fairly small compared to the jacket. So the whole idea is the stripped part of the wire should be going into the barrel, and the insulated part of the wire should only be fitting into the end of the jacket. We want to make sure that you're using the right connector. This is a 14 gauge wire and calls for a blue connector. If we were to get a yellow connector, what this guy is, you would see that, and I've removed the yellow barrel, you would see that you can insert the wire and actually the insulation into the barrel, which means if I'm crimping and I'm crimping this connector to the insulation of the wire, that's not going to be an effective connection. All right. So again, it comes down to making sure you have the right connector with the right size wire. So we're going to put these aside and let's start making a connection. We need to strip about just enough wire on this to get through the barrel, and we do want some protruding out the other end. Right, so there's no standard on how far the wire should protrude, but it should protrude a small amount. We definitely don't want to make the wire too long because we don't want this wire hanging out. Really, we just want enough to sit inside that barrel. So how can we strip that wire? So people use knives. Problem with using a knife and going around the wire is a lot of times you wind up cutting strands, and we don't want to cut any strands. That causes a problem. So this is really not a great way to do it. Some people will use a pair of cutters or a pair of dikes and try to go around and pull up on it. And again, if it starts cutting any strands or it cuts through the tin, again, that is going to cause some issues with the wire. So we really don't want to go that way. A common tool that comes with a lot of electrical kits are these little strippers right here, which are not very effective too because they have a tendency to cut the wire. So on this style, you are supposed to know the gauge of the wire, and you find it down here. And so we know this is 14 gauge wire, and we're supposed to take that 14 gauge, put it in there, and how much should we strip? You know, about 3/16 quarter of an inch. Now I've got to turn this. The whole wire wants to turn. I'm trying to strip it. I'm pulling, Okay, and what happens is a lot of times I pull the jacket off and I damage some of the wires. I've got some missing pieces and I've definitely cut into the tin. So that's not an effective way. All right, so these are really not a great tool to use. Some other tools that are out there is this style stripper. Again, you have to know what size wire it is. And basically, you can just figure out through numbering here, if it's a 14 gauge wire, we'll put it in the slot that says 14, and I can give that a pull, and that's going to strip the wire. Now, you can see that some of the material, some of the wires came off with it, even though we were on number 14. All right, so a lot of times with these, I'll start a size bigger and kind of move down to make sure I don't strip any of the wire, but not as effective. I really have come to like this style of stripper right here. And the nice thing about it is you put it on the wire and it just has these teeth that are going to grab and pull it. And I can put it on here and it takes a nice chunk of wire off without cutting any of the strands. There are some limitations to this. This will only do down to about 10 gauge wire. All right. And even 10 gauge not as effective. Really 12 gauge probably is the best. But for smaller wire, this really is the best way to go. So how much wire did I strip? About 3/16 to 1/4 of an inch. Again, we want it to fit so the insulation just meets that barrel and there's a little bit protruding. And if you look there, you can see that barrel just getting in there, a little bit of protruding on the outside. And that's exactly what I want. So now I'm ready to take this wire and I'm actually going to put it in the end of one of these ring terminals. Okay, and I'm going to make sure it fits in there nice and neat. All right, and that's about how much we want hanging out. So now, how are we going to crimp that? There are a couple different styles of crimp tools that are available. You can go back to this cheap pair, okay, and put it on there and squeeze on that barrel, in the middle of the barrel, and squeeze, okay. But how much pressure did this put on there? ABYC actually requires a pull test, right, for these different ends. And a 14 gauge wire is supposed to hold up to 35 pounds. Not the wire, the connection has to hold 35 pounds. So you want to make sure if you're making connections, you're doing a pull test. And the reality is no one's going to go get a scale and pull these things off, but you can see that with just a pair of pliers, I can easily pull that out. So if you've got a boat where there's a little bit of tension on the wire moving around, there's a good chance that the wire may pull out. So those are not really effective tools for crimping a wire. Another style you're going to see it's very common is this pair of pliers I have in my hand. We're going to strip again about 3/16. And the neat thing about this tool is there's a little adjustable spot here and you can adjust it. There's a scale. So you can kind of get the same amount of wire strippage each time. All right, so again, I'm going to put that end on there. And with this guy, we have two spots. One spot says insulated and one side says bare. All right, so with this plastic on there, that is an insulated connector. So we are using that elliptical crimp on here. We're going to put that in the middle of the barrel. All right, and we are going to squeeze. And this one is sliding out. All right, so I've got a good hold on that, and I'm going to try to give a pull on here. And we can see that this one, I got some good force on there, okay, and it won't come out. So these ones are very effective. I like these because they've got a much longer handle, so I can get a lot more grip on there. Plus, if I got a little bit bigger connection, I can push down on something and really get them crimped pretty good. Another style is the double crimper. This is a ratcheting crimper, okay, and this has two sets of mandrels in here that's going to actually crimp, and typically we're going to use this to crimp these in the barrel, and we're going to actually crimp the PVC on here to support the wire. These work really good with butt connectors too. So let's do one using the double crimper. So I've got this wire, it's already stripped. I'm going to put it on here And I've got the dot. We've got a couple different dots there, red, blue, and yellow. So we have to use the mandrel that aligns with our color connector. And so this case it's blue. So I'm going to put the blue on there, the outside connector, the wires pushed in, wires crimped in, and squeeze. Okay, and we can see that it has crimped the barrel, and it's put a small crimp, not a tight crimp, on the wire to give it some support and right to help to hold that connector on there. So let's strip this other end. And again, we'll use the blue dot on a blue connector. I'm going to put that on just a little bit in from the edge. I'm going to squeeze that, and it's a ratchet, so as you squeeze down, you'll click it, and you'll know you're all the way down, it'll pop up. Now, the only problem with these crimpers that have the ratchet is sometimes they don't work well with other brands. So if you buy a particular name brand crimper, sometimes it only works best with their particular connectors, so just keep that in mind. So we've got this butt connector on there. So how much force can I put on there? Was my connection good? We just got a basic digital fish scale here. I'm going to turn it on, and we are going to attempt to pull on this, and we're going to see how much tension I can get on this connector before it fails, or even if it fails. So I've got the wire there, all right. It's going to zero out, okay, and I'm going to start to pull on it, and I've got 36, all right. So I can put tremendous amount of force in there, and that piece has not broken, so that's a really good crimp, and that's what we need. Now, the bottom line is no one's going to go in a boat and use a fish scale and check every connection. But what we're trying to hit home is that every connection needs to be secure mechanically, all right? And also, when you put these together, they need to be secure, and they've got to be able to work electrically too. So we want to make sure that when we're crimping it and we're stripping it, we're getting the appropriate amount of wire in there and the crimp so that we're not going to have any issues with this come down the road.